Of the Cosmology Prize of the Peter Gruber Foundation and the presentation of the 2006 Fellowships for Young Cosmologists given in partnership with the IAU. Please welcome Mrs. Patricia Murphy Gruber, President of the Peter Gruber Foundation.
Thank you, Mary. Welcome to the Peter Gruber Foundation Cosmology Prize ceremony presentation. We are happy to present this award in partnership with the IAU. With the vision of my husband, Peter Gruber, we established this prize in the year 2000, and it was the first of our international prizes. We have established 5 prizes in cosmology, justice, genetics, neuroscience, and women's rights. Each award recognizes discoveries and achievements that produce fundamental expansion of human knowledge. I'd like to acknowledge the vision and leadership of my husband, Peter Gruber. It has been his ideas and the income from his successful career that entirely funds the work of the Peter Gruber Foundations.
Thank you very much. Thank you, Pat. First of all, I just want to welcome all of you to this wonderful event. I'm bedazzled by the spectator of being here in Prague and seeing this wonderful city and its unfolding. I want to make this a very brief speech, if I can. And there's an old adage that says, I throw my glass so that others will throw their jade. And many years ago, and then I'll stop. Many years ago, when I was a little boy, about 11 years old, I was in boarding school, and Brother Darcy, who was one of the teachers, loved 2 things. He loved he loved astronomy, and he loved his garden. And those people who helped him in his garden got at night to go to see the stars. And that's how I became involved and very much interested in this, in the whole issue of astronomy. And I just wanted to share that with you and tell you that it's been a wonderful trip, and I'm enjoying it enormously. And I just want to thank you so much for being here. Thank you.
Cosmology was our very first prize, and as Peter said, originated from when he was 11 years old, being able to look through a telescope. We award this Cosmology Prize annually, recognizing groundbreaking theoretical, analytical, or conceptual discoveries. Past recipients are Alan Sandage and Jim Peebles, who is here with us today. British astronomer Royal Martin Rees, Rashid Sunyaev, who is also here with us today, Alan Guth and Andre Lind, and last year, James Gunn. Before announcing the 2006 laureate, I'd like first to present our fellowships for young astronomers. These fellowships were established with the IAU with the aim of encouraging promising young investigators in cosmology. They are selected by the IAU from numerous applications. The 2006 fellows are 2, Inma Martinez Valcuesta and Hung Chand. not be with us today. She was born in Spain, and she is currently studying at the Center for Astrophysics Research at the University of Hertfordshire. She's investigating the evolution of stellar bars in disk galaxies. Hum is from India and is studying at the Inter-University Center for Astronomy and Astrophysics at Pune. He and his colleagues have found that the fine structure constant is not increasing with time. It really is constant. This is a good thing for the world of physics. I'm told it means you don't have to rewrite your theories. And now to the 2006 Cosmology Prize of the Foundation. This prize carries a gold medal and an unrestricted cash prize of $250,000. A distinguished international board of advisors has guided our selection of the 2006 laureate. These advisors are nominated by the IAU to ensure the scientific integrity of the prize. The members this year are James Peebles, Ron Akers, Jocelyn Bell Burnell, Roger Penrose, Peter Gallison, Simon White, and Jacqueline Bergeron. Owen Gingrich and Virginia Trimble advise the Foundation on cosmology matters. It is gratifying to acknowledge the serious dedication, the knowledge, and the enthusiasm that the advisors bring to the judging process. And now it's time to announce the prize. The 2006 Gruber Prize for Cosmology is awarded for groundbreaking studies looking back over 13 billion years to the early universe and confirming that our universe was born in a hot Big Bang. The 2006 prize is awarded to Dr. John Mather and the COBE team. The prize is shared by Dr. John Mather and the COBE Science Working Group, representing the hundreds of people who contributed to COBE. Before asking John Mather to accept the award, I'd like to ask two of the advisors to speak briefly about the achievements of Dr. Mather and the COBE team. Firstly, Professor Virginia Trimble from the University of California at Irvine and Las Cumbres Observatory. She will outline John Mather's personal achievements.
Dr. John Cromwell Mather is in a sense a typical American, in another sense not. He just celebrated a significant birthday, and so is on the absolute cutting edge of the baby boom and the generation whose lives were transformed by Sputnik and its successors. On the other hand, in a country of transients, he lives now only one state line away from where he was born, in Roanoke, Virginia. John grew up on a farm in Sussex County, New Jersey, where his father was working in a dairy cattle experimental station of Rutgers. His mother was an elementary school teacher, and it is clear they taught him a good deal more science than was available in the local schools, visited every other week by a bookmobile. My school had lots of books. We were visited once a year by a cow so we could see what it looked like. And Sputnik went up when John was 11, and by high school he was an enthusiastic consumer of summer school college classes in mathematics and physics. He was also even then persistent in the face of experimental failures. His first home-built shortwave radio receiver didn't work, so he got some more parts and built another one. When the discovery of the CMB was announced in 1965, Mather was a freshman majoring in physics at Swarthmore. Having read books by George Gamow, he was not surprised, though the discoverers were. 1968, bachelor's degree in hand, John was awarded both NSF and Woodrow Wilson fellowships. He accepted the NSF. It was worth about $400 more per year, a lot of money in those days. and went off to the University of California, Berkeley. And we now discover that John Mather is very far on the hedgehog end of the fox-hedgehog spectrum of scientists. For when he settled down to a thesis project in 1970, it was to work with Paul Richards on a CMBA measurement. Rocket data had shortly before apparently suggested a large excess of short wavelength emission. They, together with David Woody and Michael Werner, with some encouragement from Charlie Towns, built a suitable widget and hauled it up 12,000 feet almost to the top of White Mountain. John is the first author on the 1971 APJ letter that reports that they saw no spectral features or excesses. Next came a balloon experiment. Incidentally, physicists say experiment where astronomers would say observation. Mather and Woody drove that one in a university truck from Berkeley to Palestine, Texas, where the flight was a success but the instrument failed. Back to Berkeley, where Woody rebuilt the instrument. Later flights worked as planned and still saw no excess or feature emission. Meanwhile, Mather wrote up a thesis and headed off to New York to be a proper radio astronomer, working with Pat Thaddeus on observations of interstellar molecules. But the CMB was calling, and 2 years later he was at Goddard Space Flight Center, on track to become the lead scientist in what we now call COBE. Let's fast forward to a Saturday afternoon at the January 1990 meeting of the American Astronomical Society, a session called Cosmic Background Radiation. The COBE authors had been very brave because the abstracts had to be submitted before their 18 November launch date. Nancy Boggles, who is also here, introduced the session and the satellite. We heard from Mike Hauser and from George Smoot, and then from John Mather. He actually said rather little and put up the measured spectrum, a more perfect black body than their calibrating source, and remarked that it represented only a tiny fraction of the data. The audience spontaneously rose and broke into applause. The session chair growled into the microphone, "What are you clapping for, the universe?" And I will hand over the microphone to Jim Peebles to make just a little more clear what we were clapping for. Incidentally, that chair is here now, too. I don't know if he's in this session, but he is here.
Thank you, Virginia. Now Dr. Jim Peebles will tell about the experiment of COBE.
Mr. President, friends and colleagues, it's a distinct pleasure to join you in celebrating deep advances in physical science. I remind you that in the early 1970s, we knew space was filled with radiation. We had the idea that that radiation was left over from the early universe, but we felt pretty sure that if and where it would have the distinctive thermal blackbody spectrum. We knew that the long wavelength part of the spectrum was indeed close to blackbody. We had distinct indications that near the peak there was an excess. That situation persisted for some 20 years, during which time we theorists were forced to face the possibility that our universe is a good deal more complicated than we would have liked to have believed. We rose to the occasion. Consider decaying dark matter, or magnetized, superconducting, annihilating cosmic strings. This is beautiful physics, and it still may be part of our physical world, but it is not dominant in the energy inventory. Our universe, COBE showed us in the first of these experiments, headed up by the principal investigator, John Mather, that our universe is, at least on this scale of things, wonderfully simple. And furthermore, that this spectrum is almost uniquely interpretable as a fossil from the time when our universe was very different from now. What a fundamental advance. The second experiment on COBE, DMR, aimed to detect the small disturbances in this radiation that must be present, given that our universe is not exactly homogeneous. By the time of COBE first planned, 1974, we knew the physics of these disturbances. We had all of the theory, but we didn't know we had it. We had too many theories. We had too many ideas. More grew during the years up till 1992, was it, when COBE DMR finally produced the detection we were so seeking. During that time, a wonderful set of ideas had to be sorted out. The deep advance of DMR was to show the community the direction that it has taken since then to get now to a wonderfully well-supported, well-tested theory picture for the way the universe is expanded. Consider that we can say with certainty that our universe is expanded from a very dense state, and that we can say that because we have cross-checks, including the fact that the radiation has been disturbed in the way characteristic of last interaction back when the universe was 1,000th its present size. That physics should work that well is deeply, deeply impressive, deeply humbling. The third experiment, Mike Hauser PI, Derby, addressed a question that is still older than those we have just considered. As soon from the time that people considered seriously the possibility that the universe is homogeneous in the large-scale average, they could have faced up to the pressing issue, what has become of the accumulated starlight from the generations of stars? We are still debating that question. Derby was designed to address a question that Mike Hauser and I had been debating when he was still at Princeton University. What is the amount of radiation left over from the evolving galaxies? And Derby set us on again the right track. We have now more or less a consistent story. The amount of emission from galaxies and AGNs about adds up to what is seen. These are profound advances. I asked John yesterday, weren't you a little nervous putting 3 eggs in one basket? He was young and brash in those days. You remember, he was a postdoc when he set out in 1974 to become project scientist for a project of considerable size and importance, and he led it to such spectacular advances. A final word, the awarding of major prizes, which is a wonderful thing, I thought not so much for the individual, although that's fun, but to the community to show our respect, and to the broader community to show that we are doing things that are worth respecting. But during the 100 years or so of tradition of major prizes, the subject has moved substantially in the way it is organized. More increasingly, even in astronomy, projects involve many people. I don't think we have broken any very innovative ground in the way we've handled this, but we have at least taken a step toward recognition that these are projects such as COBE that involve great input from many people. It is really a pleasure to me to consider that we have, at least in this case, struck a good and I think proper balance. Thank you.
Thank you, Jim. Dr. Peebles was the 2000 recipient, the year 2000 recipient of the Gruber Cosmology Prize, together with Alan Sandage, for his work in theoretical cosmology. Ladies and gentlemen, John Mather.
Well, I would like very much to thank the Gruber Foundation for recognizing the work of our team from the bottom of my heart and on behalf of the whole COBE team. Now, you said out loud that great discoveries come from teams and not just from 1 or 2 or 3 people. I've just heard my talents described in a delightfully embarrassing way, but I have to tell you I didn't do this project myself at all. I think as individuals we all know our history and we know how we came together to do something beautiful. But I don't know if we really appreciate the flow of history and fate, the forces that come together for a moment to do something magnificent. Standing here in Prague, a beautiful city, maybe 1,000 years old, with a very exciting and interesting and difficult history, one can really feel it and sense it. We astronomers have been blessed by these forces. How could Hans Lippershey have known 400 years ago what he would do to astronomy? Or how could Thomas Jefferson and Ben Franklin, 2 of the first scientists in the New World, have guessed that their future taxpayers would support fundamental science for the good of all mankind, or that the benefits would be so immense? Or that the discipline that it takes to put spaceships on the moon, using slide rules to design them, would lead so far? Now to be more specific, I would like to thank some people, especially my family, who gave me great opportunity and showed me about science. My father was a scientist, my mother's father was a scientist. I thank my dear wife Jane, who encouraged me when the going was tough, which it was often, and understood what it meant, that I was terrified that I might make a big mistake while helping to lead a team of a total of 1,500 people. I thank my thesis advisor, Paul Richards, who's here today. He actually designed the prototype instrument, prototype spectrometer to measure the cosmic background radiation spectrum while I was his graduate student. I thank my fellow student, David Woody, who actually made the apparatus work after I left Berkeley and proved that it could be done. I thank my postdoctoral advisor, Pat Thaddeus, who saw that this idea actually could fly in space and helped me organize the team that we grew to write a proposal to NASA back in 1974. Then NASA headquarters, in the person of Nancy Vargas, saw that this proposal was good and chose 6 people, 4 from our team and 2 from 2 competing teams, and said we should define the new COBE mission. Nancy had leadership in this new field of infrared astronomy for NASA headquarters, and she actually backed 4 major observatories that are coming along. The first was the Infrared Astronomical Satellite, then was the COBE, now the Spitzer Space Telescope, which is flying now, and what's coming next is the Stratospheric Observatory for Infrared Astronomy, the SOFIA. It's almost done. So she did that even though the technology was very hard to develop. And I'm sure that without Nancy's leadership, our project would never have gotten started. On our science team, we had an outstanding chairman, Rainer Weiss, who actually spent some of his childhood right here in Prague. My fellow principal investigators and their deputies, George Smoot and his deputy Chuck Bennett, Mike Hauser and his deputy Tom Kelsall, and my deputy Rick Schaefer, they were brilliant to work with. But beyond all of these individual outstanding people, I have to express the appreciation of the science team for the professional engineers who actually took these challenges and made the COBE work. The Goddard engineers worked side by side with the scientists, reaching the limits and finding ways around them. And they worked like crazy. There are many stories of the ways that the COBE almost failed, but was saved because somebody was working late at night or on weekends and noticed something wasn't quite right. If you really want to know what happened, you have to read the book. So, on behalf of all of us on the COBE team, our grateful thanks and appreciation to the Gruber Foundation. We have a glorious future ahead of us. Thank you.
Thank you, Dr. Mather. I now invite you to join us at 12:45 tomorrow for the Peter Gruber Lecture, which will be given by Dr. John Mather in the Forum Hall. Ladies and gentlemen, please join us in a final salute to Dr. John Mather and the COBE team.
And now, ladies and gentlemen, let's give the floor to the Lesser Town Singers. This chorus was established in 1996 as a group of 15 young musical talents, mostly students of various high schools in Prague. Within 10 years of its existence, they have built a large repertoire focusing on spiritual music from different historical periods and countries, as well as on light genres such as swing and jazz. The lesser town singers have enjoyed the opportunity to sing in numerous cities, churches and concert halls all around the Czech Republic, and last year the choir completed a successful concert tour of the United States of America. The lesser town singers. So this was the Lesser Town Singers. And now, ladies and gentlemen, let me invite Mrs. Alena Hatravová with her lecture, Astronomy in Prague, from the past to the present.
Ladies and gentlemen, distinguished guests, welcome to Prague and welcome to this Congress Center built close to the neighborhood of ancient Vyšehrad. Its name means the upper town. According to the oldest Czech chronicles, it was here that the Princess Libuše ordered her people to found the city of Prague and where she envisaged its glory touching the stars. It was also here that the canon of Vyšehrad, recorded in the chronicle from the first half of the 12th century, some observed astronomical and meteorological phenomena. Centuries later, Johannes Kepler, whose results achieved in Prague have really reached a stellar fame, recalled Libuše in his treatise Somnium, dealing with lunar astronomy. Kepler's own work is a nice example of links between astronomy, history, and philosophy, which he also studied seriously. He was searching for historical records of astronomical events, and he also judged the impact of astronomical knowledge on the human mind. Astronomy is not only a science inseparable from other natural sciences and yielding different particular results of practical use. It is also an important part of culture. It is thus natural that, like in many other countries, astronomy has here played this role from prehistoric times. It was cultivated both by the church, in monasteries and schools, and in the courts of nobility in the medieval Czech kingdom. Let me show several examples. On the screen, you see the celestial globe from the collection of the Czech king Přemysl Otakar II, or Wenceslas II. A richly illuminated Ptolemaic star catalogue written in northern Italy in the 14th century belonged to the collection of astronomical and astrological manuscripts of King Wenceslas IV. In another codex from his library, we can find a portrait of an astronomer named Těříško,
observing the sky using a quadrant. An illumination from the book of Mandeville's Travels shows astronomers observing stars using quadrants and astrolabes, the most frequently used medieval astronomical instruments. This Czech work from the early 15th century is now in British Library. The study of astronomy in Bohemia improved significantly when in 1348 the Prague University was established by the Emperor Charles IV as the first in the Central Europe. Astronomy reached a high level there in the works of Master Christianus de Prachatic and others at the beginning of the 15th century. The importance of Prague as a site for astronomy culminated in the Rudolphine period. Prague was a cosmopolitan European cultural center under the rule of the Emperor Rudolf II. On the recommendation of the prominent Czech scholar Tadeusz Hagecius, Tycho Brahe got a position here as imperial mathematician. The cooperation of Tycho Brahe and Johannes Kepler soon ended with Tycho's death, but Kepler remained in Prague for 12 years, which were the most fruitful of his life. It was here that he wrote his main works, Astronomia Nova, Optica, and others. Instruments made by famous mechanicians on the Prague imperial court, such as Erasmus Habermal and Jos Bürgi, are preserved in the National Technical Museum as well as in many musea around the world. Several achievements in astronomy, mathematics, and physics were also reached here later, at the time of the Austrian Empire, notably by Bernard Bolzano, Christian Doppler, and Ernst Mach. Astronomy was also one of the sciences promoted by Czech patriots during their efforts in achieving cultural, economical, and political emancipation of Czech nation. Let me name Josef Jan Frič and Milan Rastislav Štefánik as examples. Prague is said to be a city of 100 towers. Allow me to remind you of 3 of them which are connected with astronomy. The first one is the Tower of Charles Bridge on the Old Town side. It was founded by the Emperor Charles IV as his triumphal arch at a unique event. In 1357, on the 19th of July at 5:31, in the place from where the summer solstice sunset is seen behind the tomb of St. Vitus in the cathedral. The importance of this structure is also emphasized by the medieval cosmological model and cryptic in its decoration. Individual sections correspond to the spheres of the Earth, the Moon, the Sun, and stars. The second tower at the town hall on the Old Town Square is equipped by the famous astronomical clock of Prague. This clockwork-driven astrolabe was built in 1410 according to designs by the master of Prague University, Johannes Schindel, using the contemporary astronomical knowledge for practical purposes of timekeeping. Finally, the third tower, which you know from the poster of this General Assembly, is the astronomical observatory of the Jesuit College of Clementinum, erected in 1722. Its purpose was not only to measure the time with increasing precision, but also to contribute to the development of astronomy itself. When the Jesuit order was dissolved in 1773, the astronomical tower became the Czech State Observatory. Its tradition continues to the present day by its successor, the Astronomical Institute of the Academy of Sciences of the Czech Republic, which gradually moved into its new site at the Astrophysical Observatory at Ondřejov. These three examples illustrate different historical roles of astronomy as a symbol in culture and arts, as a tool in daily practice, and as an advanced physical science challenging the human mind and promoting its development. The present-day sciences tend to diverge into many narrow fields that are nearly inaccessible to non-specialists. However, an important feedback into the general culture persists. This is remarkable in astronomy. For instance, one of the subjects of this meeting is the physics of black holes, whose historical roots lead to Albert Einstein working here in Prague nearly a century ago. Mathematical details of this subject are as difficult for laymen now as were the systems of epicycles centuries ago. Nevertheless, basic notions and results have become a part of common knowledge. At the end of my talk, I would like to wish you a great success for your coming meeting in revealing new secrets of the universe. And at the same time, I hope that public will get from you a new extension of the horizons of mind. Thank you very much for your attention.
Let me thank Mrs. Alena Hadravová for the first lecture of today, and let me thank you for your big attention. And now there will be the first 10 minutes break. But before, let's listen to the closing fanfare of the inaugural ceremony performed by the trumpeters of the Prague Castle Guard Band.